Hello, Algebra 1 class. I hope you guys had a great weekend and that it was restful and that the Sabbath that you spent was also a blessing to you. Just curious how you guys enjoyed the church service that we had Sabbath via Zoom. Was that a blessing to you? For those of you who were able to attend, would you like to see this continue? We would love to hear from you to know how what your reaction to the whole thing was. Pastor Archer in particular would love to know if it was a blessing to you, if you had any suggestions on how to make it better. All of these things would be really nice to hear. So if you've got a few moments and you'd like to send me a WhatsApp text or something, that would be great. Okay, today we're going to be dealing with the simplification of expressions with radicals again. In particular, we're going to be working or performing operations that involve radical expressions. So operations with radical expressions, how do you handle those? How do you proceed when you have radicals involved? And are there any special rules or methods that you would use that would be different from any other operation that involved algebraic expressions? The fact is that in so many ways, this is very familiar to you. It may look a little different, but actually you already know the processes to follow in taking care of these type of operations. Now, in our last assignment, we had a challenge problem, and I know it really did challenge quite a few of you, and you were very eager to know how do you solve that problem anyway. So I'm going to show you that, and hopefully you will see really how simple it is, because it's so much like other things that we've done in the past. So let's jump right on over there and get started. All right, so the challenge problem that we had last time looked like the following. Square root of 3 plus 2 over x. Kind of like this here. Oops. It doesn't look like this is going to work very good. And this was equal to the square root of 3 minus 1 over the square root of 3. So how do you handle a problem like this? Well, I would hope that this looks strangely familiar to you. I mean, is it all that much different than a problem that maybe looks something like this? 2 over x equals 5 over 7, maybe. How would you handle this one? 2 over x equals 5 over 7. Have you ever seen a problem like that before? You sure have. What's the method that we would use? It's called cross multiplication, isn't it? So we'd take 5 times x, we get 5x, we'd take 2 times 7, and we get 14. We divide both sides by 5, and that's how we would proceed. Okay? Something like that. Well, what's so different about this? We use the very same approach. The only difference is that we have expressions that involve radicals. So we cross multiply number 1. So we take square root of 3 minus 1, and you have to use parentheses. Okay, notice you have to use parentheses because you're taking x and you're multiplying times the square root of 3 minus 1. It's not just the square root of 3, nor is it just minus 1. It's square root of 3 subtract 1. So you have to use the parentheses. And then you will take, on the other side, it'll be the square root of 3 times the square root of 3 plus 2. Like that. And we proceed to multiply. So, well, actually, no, let's not multiply yet. Let's go ahead and now let's divide both sides by the square root of 3 minus 1, so we get x by itself. So we just divide both sides by square root of 3 minus 1. So watch this carefully, square root of 3 minus 1 times x. I'm going to divide that by the square root of 3 minus 1. Hold on a second. I want to make sure you see that the minus 1 is outside of the radical. It's not under the radical sign. And then this will be equal to the square root of 3 times the square root of 3 plus 2, all divided by square root of 3, subtract 1. Okay? Now on the left side of the equation, these two guys cancel each other out. Why don't we do that in a different color? Okay, these two cancel each other. So we're left then with x equal to this numerator. Now let's multiply the numerator. What's the square root of 3 times the square root of 3? Ah, simple, isn't it? That's just 3. That's the definition of a square root. Something times itself gives you the number. So whatever the square root of 3 is, when I multiply by itself, I get back 3. Square root of 3 times square root of 3 is 3 plus 2 square roots of 3. Like that. And then we're dividing all of that by the square root of 3 minus 1. Like so. Now, this expression is looking a little simpler now. What do we have to do to solve? Well, we have to simplify, and this is not simplified because we have a radical in the denominator. So what was the method we used to get rid of the radical in the denominator? We multiply by the number 1, but it's 1 in a special form. It is the square root of 3 plus 1 over the square root of 3 plus 1. The square root of 3 plus 1 is the conjugate of the square root of 3 minus 1. So let's go ahead and solve for this. I'm going to move over just a little bit to give me more room here. So this is going to be 3 plus 2 square roots of 3 times the square root of 3 plus 1 all over square root of 3 minus 1 times square root of 3 plus 1. Okay, now in the denominator, we have used the conjugate because we know that when we multiply by the conjugate, we have something which, when expanded, becomes the difference of two squares. Remember, a plus b times a minus b, how does it multiply? It's equal to a squared minus b squared. In this case, a is the square root of 3, and b is 1. So our denominator now will look like this. It'll equal to the square root of 3 squared, which is 3. Maybe I'll write this out to hopefully not confuse you. Square root of 3 squared minus 1 squared. In the numerator, it looks very much like the multiplication of two binomials, doesn't it? Except these are not binomials in the sense that there's no variable there, but we still have to multiply in the very same way. So we do first, outer, inner, last, okay? First, outer, inner, last, and it works just like it does with the expressions we've done back in previous chapters. So 3 square roots of 3, that's my first. 3 square roots of 3, that's my first. Now my outer, 3 times 1 is 3, plus my inner, okay, 2 times the square root of 3 times the square root of 3. Square root of 3 times the square root of 3, dealing with these two guys right here. The square root of 3 times the square root of 3 is just 3. Times that 2, 3 times 2 is 6. So this will become plus 6. Go back to my black, plus 6, okay, and then finally plus 1 times 2 square roots of 3, which is just 2 square roots of 3. This is my last term. First, outer, inner, last. I'm dealing now with the last one. 3 times 1 is just, first is last is 2 square roots of 3 times 1. Sorry, I got myself mixed up a little bit. 2 square roots of 3 times 1 is just simply 2 square roots of 3. Okay, like that. Now I collect some terms and go ahead and solve for this. So x will be equal to 3 square roots of 3 plus 2 square roots of 3 is 5 square roots of 3 plus what? 5 square roots of 3 plus 9. 3 and 6 is 9. So what I'm doing, I'm bringing together similar terms. So I'm bringing together these two guys, adding those together, and then I'm bringing this with this, adding those two together because they're similar. Notice 3 square roots of 3 plus 2 square roots of 3 is 5 square roots of 3. This is no different than saying what's 3x plus 2x. 3x plus 2x will be 5x, except that in this case it's not x, it's square root of 3. So 3 square roots of 3 plus 2 square roots of 3 is 5 square roots of 3. So you handle it just like you would other things that you've done in the past, and should be good to go. So here we go. So this will become 5 square roots of 3 plus 9 over 3 minus 1, which is 2. Okay? 5 square roots of 3 plus 9 all over 2. I think very often we write it in the other order, though. We often write it as 9 plus 5 square roots of 3 all over 2. So there's your answer. I hope that clears things up a little bit for you. That is the value of x that makes this expression true. So you go back up to the start, right back up here to the beginning. What value of x would make this thing equal? Well, there you have it. 9 plus 5 square roots of 3 all divided by 2. Well, that was a bit of a challenge problem, but I hope you see the similarity to this stuff right over here on the left. I mean, it's not all that much different than that, except that we have radicals that require simplification. So we had to use the conjugate and things like that to get it in simplified form. But aside from that, we use the same procedure. We cross multiply, we divide by the coefficient of x, and we end up with a fraction. We simplify that fraction by multiplying by the conjugate, collecting similar terms, and we get our answer. So folks, that was a challenge problem. I hope you found it enjoyable to work on. It's kind of like a puzzle, isn't it? Something fun to do. All right, let's jump on to today's problems. The first ones in this problem set are extremely easy. I think you're going to find these to be a pleasure to deal with compared to some of the harder things you've done in the past. So here we go, example number 1. Example number 1 looks as follows. 3 square roots of 5 plus 6 square roots of 5. 3 square roots of 5 plus 6 square roots of 5 equals what? Okay. Does this look hard to you? Does it look strange to you? I hope not. Is this is very much like the following. It's no different really than saying 3x plus 6x. Okay? Handled in just the same way. 3 apples plus 6 apples. 3x plus 6x. And you get 9x. Okay, this would be 9x. The only catch is that x, in our case, is equal to the square root of 5. So this becomes 3 square roots of 5 plus 6 square roots of 5 is 9 square roots of 5. Now, the thing that we could do to maybe show this a little different, we could factor it if you wanted. This isn't necessary. To me, the answer is just obvious. It's 9 square roots of 5. But if by chance maybe it's not quite so obvious, factor out the square root of 5. You see the common factor, square root of 5? Factor it out. So this would become 3 plus 6, okay? That's the square root of 5. If you were to multiply this using distributive property, it brings you right back to what you have here on the left. So this then becomes 9 square roots of 5. 9 square roots of 5. Learn how to read it so that it sounds right, 9 square roots of 5. That's like saying 9 apples. 9 square roots of 5. Or 9x. Okay, it's the same. The way you read it is the same. 9 square roots of 5. Okay, that's example number 1. Very easy one. Let's move to example number 2. Example number 2 is not much different. 3 square roots of 7. Subtract the square root of 7. Factor out the square root of 7. So this is equal to 3 minus 1 times the square root of 7, which 3 minus 1 is 2. 2 square roots of 7. Now, understand that this part right here is not really necessary to do. I think you all know that 3 minus 1 is 2. So this is like saying, it's like saying 3x minus x, except that x is the square root of 7. 3x minus x is 2x. 3 apples minus an apple is 2 apples. 3 square roots of 7 minus the square root of 7 is 2 square roots of 7. When you start to read it correctly and understand what it says, the answer is so obvious, there's really no calculation to do. So 2 square roots of 7 is our answer. That is example number 2. So we move on now to example number 3. Example number 3 is maybe slightly more challenging because it involves dissimilar terms, terms that are not similar. So it looks like this: square root of 8 plus the square root of 12 plus the square root of 18. How do you deal with something like this? Well, you begin by looking at the factors of these numbers. So what are the factors of 8? What are the factors of 12? What are the factors of 18? Well, 8 is 2 times 4, isn't it? And you might guess that I'm looking for factors that have nice square roots. So 2 times 4 is 8, but 4 has a square root of 2, doesn't it? So it makes sense that I might want to use 2 times 4. How about 12? 4 times 3. And there again, 4 has a nice square root. 18, 9 times 2. And 9 has a nice square root. So I'm using factors. I'm going to be using factors that have nice square roots. So the square root of 8 can be written as the square root of 4 times 2. And let me write this with a dot. Square root of 4 times 2. Okay? Square root of 4 times 2. So that's a dot. Okay? Plus the square root of 4 times 3. Plus the square root of 9 times 2. And you remember the rule for dealing with the square roots of products? The square root of AB was equal to the square root of A times the square root of B. Square root of AB was equal to the square root of A times the square root of B. So watch this here. Square root of AB is equal to the square root of A. And I'm running out of room. Let me back this up a little bit so you can see this better. Square root of AB was equal to the square root of A, square root of B. You remember that rule. So here we go. Square root of 4 times 2 is going to be equal to the square root of 4 times the square root of 2 plus square root of 4 times the square root of 3 plus the square root of 9 times the square root of 2, like that. So, sorry, sometimes when I'm writing on my screen, for whatever reason, it doesn't write. I'm writing with my finger and then it starts to write, but then sometimes it doesn't. So I have these little pauses that are probably annoying. I'm sorry for that. Anyway, the square root of 4 is what? 2. Square roots of 2 plus 2 square roots of 3 plus 3 square roots of 2. Now when you look at these two guys, I hope you see that this one is similar to this one. Okay? We have 2 apples plus 3 apples plus 2 oranges. Okay? 2 apples plus 3 apples plus the 2 oranges in the middle. Where are my oranges? These are my oranges right here. Okay, so 2 apples plus 3 apples, bring that together and I get 5 apples, but I still have my 2 oranges that I have to add on. So notice then this becomes 2 plus 3 is 5 square roots of 2 plus 2 square roots of 3. So 5 apples plus 2 oranges, if you like. So again, if you interpret it in the right way, if you read it in the right way, I firmly believe that if you read it like I'm trying to say here, you know, this one here is 2 apples plus 3 apples, okay? Plus my 2 oranges right here in the middle. If you read it like that, I believe that it will make it easy for you, where these things become simple to work out. So there you go. That was our next example. I hope that was helpful. And for some reason, my screen seems to have frozen. Here we go. So that was example number 3. Let's now go to example number 4. Example number 4, we'll try to shake this up a little bit, make it more exciting for you. All right, here we have something like the multiplication of a binomial by a term out front, by some constant. Except it's not really a binomial as we know it that involves variables. Instead, it's the sum multiplied by another number. So watch this carefully. Square root of 3 times the square root of 7 plus 3 square roots of 2. Okay? Just use the distributive property. This becomes the square root of 3 times the square root of 7 becomes the square root of what? Square root of 3 times 7, like that. Plus, square root of 3 times 3 square roots of 2 is 3 times the square root of 3 times 2. Think about that for a little bit, see if it makes sense for you. Okay, in the first term, we have 2 square roots multiplied together, so we can write it as the square root of their product. The square root of their product. And then in the second case, we have square root of 3 times 3 square roots of 2. It's 3 numbers being multiplied together. It's square root of 3 times the square root of 2. Okay? And the 2 square roots, you can write it as the square root of their product, and with the 3 out front multiplying that. So in the first case, you have the square root of 21 square root of 21 plus 3 is the square root of 6. Square root of 21 plus 3 square roots of 6. Okay? Moving ahead, let's do example number 5. Example number 5. We have, in this case, a triangle, and we're going to find its area. You remember the area of a triangle is 1/2 the base times the height. 1/2 the base times the height. Okay, so here's our triangle, and we now need to find its area. How do we calculate area? Well, the way we do it, we go 1/2 base times height. So 1/2 base times height. So area is equal to 1/2 of the base times the height. That's our basic formula that we've learned long ago. The only thing here is that the base and the height are expressions involving radicals. So we say then that the area is equal to 1/2 of the base. The base is 2 square roots of 3 plus the square root of 5. And we're going to multiply that by the height, which is 4 square roots of 3 plus the square root of 5. Sorry, I'm kind of out of room here. Let's keep on going down here and see if we can solve this. So the area will be 1/2. Well, you know what? I think what I'd like to do, okay, this thing froze on me for whatever reason. I don't know what's happened. I think what I would like to do here is to take this half and multiply it right now, okay? So what's 1/2 times 2 square roots of 3? This would be 1/2 times 2 square roots of 3, like that, plus 1/2 times the square root of 5. Okay? And then all of this is still multiplying my second term, which is 4 square roots of 3 plus the square root of 5. It's looking really sloppy, I'm sorry. Okay, let's just keep going. Sorry for this, for the mess. Right, so we take 1/2 times 2 square roots of 3 is just square root of 3 because the 2's right here cancel. Okay, the 2's cancel. Plus half times square root of 5 is square root of 5 over 2. This is going to be multiplied by 4 square roots of 3 plus the square root of 5. We still have our second term that has to be multiplied there. So now we use FOIL, first, outer, inner, last, to multiply this. So the first square root of 3 times 4 square roots of 3. Okay. Square root of 3 times 4 square roots of 3 is 4 times 3, because the square root of 3 times the square root of 3 is just 3. So this is 4 times 3, or 12. Okay, 4 times 3, or 12. That's my first term. Outer, square root of 3 times the square root of 5 is the square root of 15. Square root of 15. Okay, plus inner, square root of 5 over 2 times 4 square roots of 3. Well, little trick here. This 2 and this 4 right here, the 2 goes into 4 2 times. So it's 2 times the square root of 15. I hope that can be seen. Let me go ahead and not mess those up right there. Let's do it like this. Say plus 4 over 2 times the square root of 15. Okay, and then my last term is the square root of 5 times the square root of 5 over 2. Square root of 5 over 2 times 5, square root of 5. The square roots of 5 multiplying each other gives us just 5 over 2. This becomes 5 over 2. Now, doing a little simplification, we need a common denominator. Sorry. We have here square root of 15 plus 2 square roots of 15 is 3 square roots of 15. So this becomes 12 plus this guy right here is just simply 2. Okay? So 2 apples plus the other apple. So 2 apples plus this apple here gives us 3 apples. So this becomes 3 square roots of 15. Okay? 3 square roots of 15. Plus the 5 over 2. Now we could make this simpler by getting a common denominator. 5 over 2 plus 12 over 1. This becomes 24 over 2, right? When you get a common denominator. So let's write this as 12 plus 5 over 2 plus 3 square roots of 15. And then we need a common denominator for these two guys here, common denominator. Okay, so the way we accomplish that, we write it as 24 over 2. So this becomes 24 over 2 plus 5 over 2 plus 3 square roots of 15. And 24 over 2 plus 5 over 2 is 29 over 2 plus 3 square roots of 15, like that. So there's your answer. Kind of cool. This is the area. Okay. That's our area. 29 over 2 plus 3 square roots of 15. Interesting. Cool problem. Let's move on. That was example number 5. Now we move to example number 6. Example number 6 is as follows. 5 square roots of 2 plus 3 square roots of 5 we're going to multiply by 2 square roots of 10 minus 5. Okay? First outer inner last. Okay? First outer inner last, FOIL. So maybe I should write that down here. FOIL, first plus outer plus inner plus last, FOIL. First outer inner last. What's my first term? It's going to look like this. 5 square roots of 2 times 2 square roots of 10. Oops. 5 square roots of 2 times, I'll use parentheses, 2 square roots of 10. Okay? This is, I need to write this smaller, folks. I'm going to run out of space. Okay, see if I can do this smaller. 5 square roots of 2 times 2 square roots of 10. Okay, that's my first terms. Plus my outer now is 5 square roots of 2 times what? Times minus 5. And okay, and then inner plus 3 square roots of 5 times 2 square roots of 10. And then minus 3 times 5 is 15 square roots of 5. Sorry, I ran out of room there. 15 square roots of 5 on the end, okay? So let's do some simplification. 5 times 2 is 10, and 2 square root of 2 times the square root of 10 is the square root of 2 times 10, or 20. So let's bring this together now. Let's write this as 5 times 2 is 10 square roots of 20 plus, actually minus, okay, 5 times 5 is 25 square roots of 2 plus 3 times 2 is 6 square roots of what? 5 times 10, 50. Okay, minus 15 square roots of 5. Okay. Now we can start making sense out of this. You look at it and you, I hope you see that My screen's stuck on me again. Hang on. I got to try to fix this. Hang on a second here. Okay, I'm sorry. I don't know what went wrong there, but my screen locked on me for a bit, but I've gotten it freed up now, so it seems to be moving. All right. So the square root of 20 can be written as 4 times 5, right? Again, we are looking for factors of the radicands that have nice square roots. So let's write this as 10 times the square root of 4 times 5, okay? Minus 25 square roots of 2. I can't do anything with square root of 2. It's a prime number, so there's no point in trying to do anything there. Now, the next one is 6. The square root of 50 can be written as what? 25 times 2. And the last one, 5 is a prime number, so it's just 15 square roots of 5. Square roots of 5. So in the first case, this is 10 times the square root of 4 times the square root of 5. The square root of 4 is 2. So this is 10 times 2 times the square root of 5 minus 25 square roots of 2 plus 6 times 5. Square root of 25 is 5 times the square root of 2 minus 15 square roots of 5. So my first term, 10 times 2 is 20. Square roots of 5 minus 25 square roots of 2 plus 6 times 5 is 30. Square roots of 2 minus 15 square roots of 5. Okay, once you get to this point now, you just look to say, where are my apples and where are my oranges? Huh? Look for your similar terms. So this is similar to this. And this one is similar to this one. So you bring the like terms together. Okay, 20 apples minus 15 apples is 5 apples, right? My apples are my blue ones. So right here, 20 apples minus 15 apples is 5 apples. Okay, so let's move down here and go ahead and work on this. And don't tell me this thing's messing up on me again. Yep, it's frozen on me again, folks. I don't know what's causing this. Hold on. Okay, seems like we got it freed up again. I'm not quite sure what causes these delays, but anyway, so my 20 apples minus 15 apples is 5 apples. So I got 5 square roots of 5. Okay. Minus 25 square roots of 2 plus 30 square roots of 2 is 5 square roots of 2. Okay. So 5 square roots of 5 plus 5 square roots of 2. How's that? 5 square roots of 5 plus 5 square roots of 2. Well, that was quite a process to get to that answer, but it all worked out. 5 square roots of 5 plus 5 square roots of 2. So there's your answer for this problem right there. Okay, cool. Let's do another example. That was example 6. Now we go to example number 7. Example number 7 is 3 square roots of 50 minus 3 square roots of 32. Okay, 3 square roots of 50 minus 3 square roots of 32. Okay, so there's my problem. How do you simplify that down? Well, again, we use the same technique. We look for factors of the radicands that have nice square roots, okay? So to do that, you say, well, what is 50 anyway? Okay? 50 is 2 times 25, isn't it? So we can write this as 3 times the square root of 25 times 2 minus 3 times the square root of, what would you say? Factors of 32. Does 1 have a nice square root? Sure does. 16 times 2. Okay. Now I break these apart, so this becomes 3 square roots of 25, okay, times the square root of 2, minus 3 times the square root of 16 times the square root of 2, and of course the square root of 25 is 5, so this is 3 times 5 times the square root of 2, minus 3 times 4 times the square root of 2, okay? And then 3 times 5 is 15 square roots of 2 minus 12 square roots of 2. 15 apples minus 12 apples is 3 apples. 3 square roots of 2. There you go. Answer. Cool. Isn't that nice how that worked out? 3 square roots of 2. That was example number 7. Let's go on to example number 8. Okay. Example number 8 involves fractions. The square root of 1/5 minus the square root of 5. Okay, how do we handle this? Square root of 1/5 minus the square root of 5. Well, do you recall that if the radicand involves a fraction, it's not in simple form? We've got to break this thing apart. So we multiply the 1/5 by 5 over 5. We multiply it by the number 1, but we do it in a way that gives us what we want. So we take the 1/5 and we multiply by 5 over 5. Okay. Minus square root of 5. And again, the reason we're doing this, we want the denominator to be a perfect square. 5 times 5 is 25. 25 is a nice square root. So that's why we chose to have our 1 as 5 over 5 instead of something else. So this becomes the square root of 5 over 25, subtract square root of 5. Okay, so got my screen to roll down again. So here we go. This becomes the square root of 5 divided by the square root of 25. You remember that rule, don't you? The square root of a over b is equal to the square root of a divided by the square root of b. Remember that rule? Okay. So here we have the square root of 5 over 25. That's the square root of 5 over the square root of 25. Minus, of course, the square root of 5. So this becomes the square root of 5 over 5 minus the square root of 5. Can we simplify this? Well, yeah, we can by getting a common denominator. So if you like, this, of course, is over 1. What's the common denominator? Square root of 5 over 5 minus the square root of 5 over 1. We need the common denominator of 5. So we multiply our second term by the square by 5 over 5, excuse me. So this becomes square root of 5 over 5 minus square root of 5 over 1 times 5 over 5, like that. Then I get a common denominator. Again, 5 over 5 is just 1, so we haven't changed it, the value of the fraction. So this becomes 5, square root of 5, sorry, square root of 5 over 5 minus 5 square roots of 5 over 5. And what is square root of 5 minus 5 square roots of 5? Well, we can write it like this. Okay, and then I hope you see that this is like an apple minus 5 apples, x minus 5x. Okay, x minus 5x would be minus 4x. An apple subtract 5 apples is negative 4 apples. So this becomes negative 4 square roots of 5 over 5. And I should be careful how I write this. Oops, I went too far. This thing sometimes is so slow to respond. Like that. So what I was trying to do was to write it in a better form. So this is like saying an apple minus 5 apples, which is negative 4 apples. So I'd already mentioned that to you. What I needed to do was to write the negative sign out front like this. And I was a little careless the way I was writing it, which is why I was trying to redo it. Sorry for the wasted time. This becomes as follows: minus 4 square roots of 5 over 5. And the negative sign should be in front of the fraction. Okay? I want to be technically correct. It should look like that. Negative of 4 square roots of 5 over 5. Okay? I hope that example brought a little more clarity to some things. Hopefully this is starting to seem easier to you. Let's move to example number 9. Example number 9. Example number 9 is, again, involving some fractions. So this is 2 times the square root of a half plus 2 square roots of 2 minus the square root of 8. Okay, how do we simplify this one? Well, again, we break things apart in this first fraction, the 1/2. So it's the square root of 1 over the square root of 2, if you like. There's different ways you can proceed. I prefer to deal with the radicand under the radical before I break it apart into 2 square roots. So I prefer to do it this way. 2 times the square root of 1/2, I multiply that by the number 1, 2 over 2. Okay? You can see why I did that, I hope, because the square root, or sorry, 2 times 2 is 4, and the denominator then will be a perfect square, which I can simplify easily. Plus 2 square roots of 2 minus, now I look at the 8 and I say, 4 times 2. So this is the square root of 4 times 2. Okay? So in my first term, then I have 2 times the square root of 2 over 2. And maybe I'm going too fast. Let me slow that down just a little bit. Okay, so this becomes square root of 2 over the square root of 4. Let's do it like that. Plus 2 square roots of 2 minus, okay, square root of 4 times the square root of 2, which simplifies down now. This becomes 2 square roots of 2 over 2 plus 2 square roots of 2 minus 2 square roots of 2. Okay? So in the first case, what happens here? Cancel, cancel, right? And I'm just having the square root of 2. This becomes the square root of 2 plus 2 square roots of 2 minus 2 square roots of 2. What happens to these 2 square roots of 2 here? 2 square roots of 2 minus 2 square roots of 2. These two guys right here do what? You wipe each other out. It's like 2 apples minus 2 apples is no apples. But I still have the first square root of 2 that remains out front, so the answer just becomes the square root of 2. Again, a very simple answer that we end up with, just the square root of 2. So there you go, that's our answer. And now finally, we come to example number 10. Example number 10. And what do you say we leave it there? Example number 9. Or do you want a word problem? And maybe one word problem, just to make life fun. Let's choose a nice word problem and do it, okay? Okay, example number 10. This is similar to a problem we did the other day. If you recall, in electricity, if you're calculating power, current, things like that, we have this expression, the current is equal to the square root of the power divided by the resistance. Now, power is measured in what? It's measured in watts. Okay. Power is measured in watts. And resistance is measured in ohms. They use that funny little symbol, ohms. It's spelled O-H-M-S. Okay. I usually throw in a little bit more than what the book would do because I understand this stuff and I've taught it many times, so might as well tell you. Remember? Short, repetitive exposures. You want to learn? Then don't get upset when you see something that hasn't been explained very well. Just let it, register. Hopefully it'll be easier next time. Resistance measured in ohms. Power measured in watts. Okay, so here we go. I is equal to the square root of P over R. Now, the question is, if you have a microwave oven, which is running at a power of 850 watts, 850 watts. Often they use W to mean watts. If you look on many electrical appliances, you'll see the W, which means watts. Sometimes they put VA to mean a volt amp, which is a watt as well. Okay. Anyway, 850 watts divided by a resistance. If that microwave oven has a resistance of 5 ohms, what will be the current that is flowing? Okay. Well, what's 850 divided by 10? It would be 85, right? You'd move the decimal back one, it'd be 85. If you divide it by something which is half as big as 10, namely 5, it would be twice 85, or 170. So here the current is equal to the square root of 170, and the answer will be measured in amps. Okay? What is the square root of 170? Well, it's roughly equal to 13.04 amps. AMPS, or just A for amps, but AMPS, amps. 13.04 amps will be the current flowing through the wire. Now, if you're putting in a circuit breaker to protect that microwave oven, it better have a capacity greater than 13 amps. Otherwise, it's always going to be blowing. If you put in a fuse, that fuse would always be blowing if it's not big enough. So ordinarily, they would put something like this on a circuit breaker of about 20 amps. And hopefully, it would not blow very often, right? You don't like your circuit breakers to be popping off on you. But anyway, 13.04 amps. So that was example number 10. And I think that wraps it up for us today. We should be good now to move on to an assignment. So with that said, folks, I hope you have a good time working on this assignment. It'll be up a little bit later today. I have a meeting in the morning. As soon as I get that meeting done, I will have an assignment up for you in the afternoon, probably by more or less 3 p.m., maybe a little earlier. I'll try to get it up earlier. I know that Hakyung, you're ahead of us by like 6 hours, I think it is. So that would be getting late for you. But in any event, maybe I could have it up by around 1, maybe 1 o'clock I can have it up. I'll try. So good luck on your assignment, and I hope you guys have a happy time solving these problems. These seem, to me anyway, to seem a little bit easier. So best of luck to you. If you have any questions, you can always text me. You guys don't communicate much. You're pretty quiet, and either that means it's super easy, or maybe it's so hard that you don't know what to ask. And I hope it's the first thing, not the last. This time I did not put little phrases in this video and then make you put them all together. So I hope you'll just use good sense and watch this and learn. Okay? Have a great day. Take care.